My name is Luther Jenkins, and I'm an aerospace research engineer at the NASA Langley Research Center. I'm currently assigned to the Flow Physics and Control branch, where I do fundamental research on a variety of shapes and aerodynamic devices. I got involved with NASA during the sophomore year when I was in college. I applied to the LARS program, which is the Langley Aerospace Research Summer Scholars Program, a long acronym. But it was a program designed for college juniors, seniors, and also first-year graduate students to get them exposed to research and engineering and inspire them to go on to graduate school. While I was in that program, actually I was in the program for 3 years, I was assigned to the hypersonic propulsions branch, where I did research on scramjet engines. And scramjet engines actually were used on the X-48 and the X-51, which recently broke the Guinness Book of World Records for speed. They went Mach 7 and Mach 10. So besides my tenure in the hypersonics propulsion branch, I've also worked on a variety of other projects while at NASA. I've worked on doing flow physics research on fighter aircraft, looking at ways to reduce noise on passenger aircraft. I've done research on automobiles, looking at the flow field over the different automotive shapes. I've also participated in the return to flight activities, where we were trying, after the Columbia accident, to find what may have caused problems with the debris coming off of the external tank. So we did research in various tunnels to actually see how the flow, air flows over the tank and what may cause the foam to actually come loose. And it was very rewarding to see the flight, return to flight take off after it received flight rationale. I'm currently working on helicopter research, and we're actually trying to develop ways to make helicopters more commercially viable. They have a possibility of significantly reducing the delay times at airplanes or at airports, and we're developing technologies for this vehicle that can carry 90 passengers. So you would come down, land off of your regular aircraft or airplane, hop on this passenger helicopter, and it may take you to different remote sites where there may not be a major airport. It also could be used for search and rescue operations where you have to evacuate a large number of people. But the technologies required for that don't exist today, so we're having to really address a lot of technical challenges. The most exciting aspect of my job is working with great people, realizing that no one person knows everything. You really rely on your colleagues to bring their collective talents and gifts to the table, and that enables us to really address problems that have never been looked at before. And also it gives you unique perspectives. So I really enjoy working with teams and a variety of people, and I also am very excited about learning new things every day. And I can certainly say that since I've worked at NASA for 21 years now, every day has been exciting from the aspect of being able to learn something new. The topics that we learn in school, and I always relate it to having a toolbox. So you learn science and math and English and a lot of other social studies. All of those are tools which enable you to solve problems. So when in school, you may not be able to see the direct application, but once you come out of school, you have that toolbox and you're facing new things you've never seen before. But with that foundation, you can start applying some of these tools, and that allows you to kind of see things from a different perspective and be able to solve problems or answer questions that you may not have even imagined that you could answer. So I really see the topics that you cover in school as being tools to solve problems.